So let's go ahead and do some examples. Again, I'm keeping the angle 30 degrees so we don't have to pull out the calculator. Okay, so here we are given triangle PQR. Okay, I recognize its side-side angle because angle P, side little p. Okay, once you see that, it's going to be this case. Okay, so I would look at side opposite the given angle. How does it compare to that? Well, it's less. So we're going to need the height. Okay, it might help to draw the picture. Okay, so I always draw it like this. P is going to have to go here. Side P is going to have to go here. Other given side here. Okay, same numbers that we used before, but we're actually going to solve the triangle this time. Okay, we're going to need to figure out the height, which we said would always equal this top side, 6, sine of this angle, which is given as 30. Okay, sine of 30 is 1/2, so again we get height equal to 3. So this is our worst case scenario. Okay, we have two triangles possible. Okay, so if it helps, you can draw the two triangles. Okay, but you're always going to solve this one with the non-obvious obtuse angle. Okay, this one still could be obtuse, but um, again, the other one is clearly obtuse. Okay, so you're going to solve this one first. Okay, so 30, that's P, and R is 6, so that makes this big R. Little p is 4, and that makes this Q up here. That makes this side Q. Now, since there's two triangles possible, again, I'm going to label all these things I'm finding with subscript 1. And then, when we're done, we will find these things. Okay, all subscript 2. Okay, so let's go ahead and break this down into two parts. Okay, so we need to figure out angle R1. Here's a case where I'm finding an angle. Sine R1 over its opposite side, 6, has to equal sine of 30 over its opposite side, 4. So I'm using the reciprocal version that I used on the last video because now I'm finding an angle first. So sine of R1 has to equal 6 times sine of 30 over 4. Now this happens to be a nice enough numbers where I don't need to pull out the calculator yet. Sine of 30 is a half. Half times 6 is 3. So we get sine of R1 equal to 3/4. That's not a nice ratio to know the angle, so I'm going to have to use inverse sine to calculate R1. Take a moment, pull out your calculators, and close that up, close that up. Okay, so it's inverse sine, remember, is second sine, 3/4. Okay, and gives us back 48.59037789. That is clearly degrees. Okay, again, remember last time we changed it to degree mode. It stays in degree mode until you change it again. Okay, so I'm going to move this over here. Okay, notice I am going to round my angles to the nearest degree. So this is 49 degrees. Just makes our arithmetic that much easier. Okay, so R1, I'm going to go ahead and label as 49 degrees. Okay, Q1 is easy now because the sum of three angles in a triangle has to equal 180. So Q1, it's still approximately because I'm going to go 180 minus the sum of the other two angles. But remember, I estimated this one to be 49 degrees. Okay, so it's better to use the approximate. And again, it's Q1. So this would equal about 180 minus 79 is 101. Okay, so notice, again, that's where I said this does not have to be an acute angle. I know I was referring it to as an acute angle, but it kind of looked like one. It could be obtuse. So this one is 101. So it is an obtuse angle, acute triangle, or acute triangle, excuse me. It's an obtuse angle, so it's an obtuse triangle. Okay, an acute triangle has all acute angles. An obtuse triangle has one obtuse angle. Okay, question is, can I have more than one? Hope you know the answer. If you don't, ask me tomorrow in class. Okay, so I got 2 out of the 3 things I need to find. Okay, I still have Q1 left. And again, I need to use law of sines for that. So let's go ahead and work down here. I'm going to leave a space here for side Q1. Probably going to have to approximate it. So I'm boxing my answer without Q1 yet. I'm going to do the work down here. Okay, so let's go back. I'm looking for side Q1, so I'm going to put that on top, save me an algebraic step, over sine of its angle, which we just said was 101, its opposite angle, has to equal. And again, you have a choice here. But since I rounded 49 degrees, I'm going to again use these 2 values. Okay, so this part, I use it twice. Okay, so this time it's the reciprocal though. So 4 over sine of 30 degrees. Okay, now sine of 101 degrees I don't know offhand. I do know sine of 30 is a half. And 4 divided by a half is 8. Sine of 101. Okay, so we'll plug that into the calculator. And we'll clear that out. 8 times sine 101. About 7.9, because again, my instructions will always be round to the nearest tenth for sides. So nearest degree for angles, nearest tenth for sides. So let's fill in our box. Now, again, we're not done. Going back up to the beginning. Okay, this was 2 triangles possible. It was the red case. Okay, so you still need to solve this second triangle. But the work does speed up a bit. Because remember we said, even though my picture is not drawn that way, these 2 base angles are congruent. That means this angle in here is supplementary to this angle. And if these 2 angles are congruent and these 2 are supplementary, then these 2 have to be supplementary. Okay, so to figure out R2, it's just going to equal 180 minus R1. Okay, R1 we approximated to be about 49 degrees. So this is 180 minus 40 is 141.31. Now if you notice, that also equals the sum of these two angles, and that will be true. Okay, but it might get confusing because you're looking at two different triangles, so I'd stick with R2 equal to 180 minus R1. Okay, so once we know that, again, we know P is 30. This now is 131. So that means Q has to be, that's right, 19 degrees. Okay, so Q2 we get from going 180 minus the sum of P and R2. Okay. Again, this is approximately because P is exact, but R2 we rounded. Now you don't have to show all this arithmetic. I'm trying to explain it, so I'm showing you how we get our values. Okay, so that one's 19 degrees. Again, we were given this 30. We were given R2 as, or excuse me, little r is 6. We were given little p as 4. Okay, so now, again, I have my choice for setting up my law of sines. But again, I'm going to use these two because they were given. So I couldn't mess that up too badly unless I read the problem wrong. So I'm solving for a side, so I put that on top. Sine of 19 degrees has to equal 4 over sine of 30, which again, just like the last problem, okay, it's going to equal 8 because sine of 30 is 1/2. 4 divided by 1/2 is 4 times its reciprocal. So that's 8 sine of 19. Okay. And technically 19 is an approximation, so that should be approximately. Got to use calculator because I don't know sine of 19 off the top of my head. Clear that out. 8 sine 19. Enter. We got about 2.6. Okay, so Q2. Okay, big Q2 and R2. So it's bad because we had to find 6 things, but 2 of them were just subtracting from 180. Okay. So we only had to use the law of sines one more time. Okay. So there's our answers. Now it'd be nice if we organized our answers a little bit better, but running out of time, so we got to move on. Okay. Obviously, I started with this case because it's the worst case. It takes the longest. So the next 2 examples shouldn't be as bad.